Okay, today I want to go over just some more gas law questions. So I'm going to have two videos just going over some different things. So the first one is I want to do a practice problem similar to one of the ones we did in class on Boyle's law and Dalton's law. And then we'll do another video on the free response questions from last year's AP exam, which cover gas law stuff and kinetic molecular theory stuff. And I wanted you to see how it looks on the actual AP exam, and how many points were allotted to this chunk of our curriculum. So 3-1 and 3-2. Okay, so let's look at the first practice problem here. Okay. So if you remember, this is a practice problem we did in class, where we have this kind of container. It has some gas on this side, it has some gas on this side, and it's got a stopper in between. And basically they just want to know what's going to be the total pressure of the system once we open this up. Okay. So what we have to understand is the gas over here will uniformly fill the whole thing now, and the gas over here will uniformly fill the whole thing, and they'll just mix together uniformly. And so if we think about it, over here, this gas, which is occupying 3 liters, will now occupy the total volume, which would be 3 liters plus 9 liters. And this gas initially occupies 9 liters, and it'll go from 9 liters to 9 plus 3, so 12 liters. So both gases, after the valve's been open, will now occupy 12 liters. This one is 9 liters to begin with and then goes to 12 liters, and this one is 3 liters to begin with and goes to 12 liters. And so we're assuming that the temperature remains the same, so temperature's constant, and the amount of gas isn't going to change. Now we're going to mix the two gases together, but the total amount that's in this container, even though it's opened or closed, is going to remain the total amount of gas there. So when temperature and amount of gas are constant, what's left? Pressure and volume. So we should be thinking Boyle's law, P1V1 equals P2V2, but we would do that for both gases. P1V1 equals P2V2 for this gas, P1V1 equals P2V2 for this gas, and that would give us the partial pressure, the new pressure of this gas, the new pressure of that gas, and all we have to do is add them up to get the total pressure after we open up the stopper. All right, so we did this one in class, let's go do a new one, okay? All right, so here we go, similar thing. So over here I'm telling you that this volume is 3 liters and it has 5.2 atmospheres of helium gas. Okay, great. Over here it's 2 liters and it's initially 7.9 atmospheres of hydrogen gas. All right, and we just want to know what's going to happen when we open up that valve. So we know all the hydrogen is going to end up mixing throughout the whole thing, and all the helium is going to end up mixing throughout the whole thing. And since we're told that, we're not told anything about the temperature, we can assume that stays the same, and we're not told anything about changing the amount of helium or the amount of hydrogen. That's going to remain the same. So again, the only variables are pressure and volume here, and so we should be thinking Boyle's law to begin with. All right, so if the stopper between the bulbs is removed, what will the final pressure be inside the container? All right, so assuming constant temperature, no reaction takes place, right? If you're told a reaction takes place, then that would change things. It might end up kind of being a stoichiometry problem. We'll show some examples of that when we get to equilibrium. But a hint that no reaction is going to take place here is this is helium and it doesn't react with anything. So all that's going to happen is the gases are going to mix, but they're not going to react with each other and change into something else. Okay, so the gases just mix. Okay, so we're going to use Boyle's law for both gases individually, and so let's understand what we're doing. So the helium is initially 5.2 atmospheres at 3 liters, But when we open up the stopper, now the total volume is going to be 5, 3 liters plus 2 liters. So the total volume occupied for the helium is going to be 5. And the new total volume occupied by the hydrogen will be 5, 2 plus 3. Okay? So let's do P1V1 equals P2V2 for the helium, and then we'll do the same thing for the hydrogen. All right? So for the helium, initial pressure, initial volume, here's our final volume. Let's solve for the final pressure. So the new pressure will be 3.12, and that should make sense. The helium's occupying, the same amount of helium's occupying a bigger space, so the pressure of helium is going to decrease, right? As volume increases, pressure decreases. So we go from 5.2 to 3.12. Okay, great. So that's our new partial pressure of helium. That'll be the pressure due to helium. Okay, now we'll do the same thing for the hydrogen gas. This was the initial volume, the initial pressure, the final volume. Notice the final volume for both gases is the same because we're putting them into the same size container. So when we solve for P2 for the hydrogen, it comes out to be 3.16 atmospheres. And then we just have to understand that if we know the pressures of each individual gas in the system, we call those partial pressures. To get the total pressure, we just add them up. So if we do the partial pressure of the helium that we just figured out, plus the partial pressure of the hydrogen, we add that up and we get our total pressure. So when, assuming the temperature doesn't change, this would be the final pressure of our system once all the gases mix evenly in that container. Okay, so hopefully that's pretty simple, but for some for some students it's just I don't know. For some reason it's like a difficult question to get around. For some reason, a lot of students have trouble with it. So I just wanted to make sure we reviewed one of those. All right. So we'll call that a day for this video, and I'm going to come back a little bit later, and we will be discussing all of the Unit 3 stuff. Not all the Unit 3 stuff, but the 3-1 and the 3-2 stuff, gas laws and KMT stuff that was on last year's, the 2021 AP exam on the free response. So we'll get into that here in a second. Have a great one.